Hello grade 9 students! Welcome to my channel, Mathematics and Me. In this video, I will discuss the first topic in quarter 4 of Mathematics 9. And this topic is illustrating the 6 trigonometric ratios, sine, cosine, tangent, secant, cosecant, and cotangent. And the code of this topic is M9GE4A1. And as you can see below, I have here a hashtag Sokatowa and Shoshakao. And later on, you will learn the meaning of these acronyms. So let us now start. So, by the way, this is the learning activity sheet number 1 or last one, focusing on illustrating the 6 trigonometric ratios. And for the objective of this last one, you as a student must illustrate the 6 trigonometric ratios, which are the sine, cosine, tangent, secant, cosecant, and cotangent. So let's start with this learning activity or definition of terms. So we have the terms right triangle, reference angle, hypotenuse, legs, and trigonometric ratio. So let's start first with this right triangle or the term of right triangle. So let's say for example we have triangle ABC. So this is triangle ABC. So how will this right triangle become a right or can be considered as a right triangle? This triangle ABC can be a right triangle if one is right angle and the other two are acute angles. So in this triangle ABC, angle C is a right angle, and right angle measures 90 degrees, while the two angles are acute angles, which measures less than 90 degrees. So if this triangle ABC has one right angle and two acute angles, we can consider this triangle ABC as a right triangle. Now, let's have reference angle. So reference angle is any of the two acute angles in a right triangle. So since triangle ABC is a right triangle, any of the two angles of this right triangle can be a reference angle. Any of the two acute. It means angle C cannot be a reference angle because angle C is not an acute angle. So the reference angle can be angle A or angle B. So it can be angle A or angle B, and they can be a reference angle. How about the hypotenuse? So hypotenuse is the longest side in a right triangle and usually opposite the right angle. Longest side and opposite the right angle. So in these sides of triangle ABC, which is the longest side and which is opposite the right angle? So we have here side AC, side AB, and then side BC. So among these sides, which is the longest? The longest is, AB. How about opposite the right angle? So the right angle is angle C. So which is opposite the right angle? It is side AB. Therefore, side AB is the hypotenuse. So this side is the hypotenuse. AB is the hypotenuse. How about legs? When we say legs, these are the sides of a right triangle forming the right angle. Again, our right angle is angle C. So which sides of the triangle form this angle? And that sides are side AC and then side BC. Therefore, if AB is the hypotenuse, the legs are AC and then BC. So these are the legs. Side AC and then side BC. While the hypotenuse is side AB. Again, to summarize, a triangle is right if it has one right angle and two acute angles, and the reference angle can any be of the two acute angles in a right triangle. The hypotenuse is the longest side and opposite the right angle, while the legs are the sides which form the right angle. And let's have this last term, trigonometric ratio. When we say trigonometric ratio, it is the ratio that describes the relationship between side and angle of a triangle. So to understand more what is trigonometric ratio, let's have this illustrative example. So in a right triangle ABC, angles are labeled by capital letters or uppercase. So in this figure, the angles are angle A. So these are angle A, angle B, and then angle C. So they are labeled by capital letters or uppercase, while the sides are labeled by small letters. So these small letters A, B, and C are the sides of the triangle or right triangle. So they are in lowercase. So side C is the hypotenuse. Again, this side C is the hypotenuse. Why? Because side C is the longest side and opposite to the right angle, which is angle C. While sides A and B are the legs. So these are the legs, side B and then side A. And take note that legs can be designated as opposite side or adjacent side depending on the reference angle used. So, yung legs natin, pwede siya maging opposite, pwede din siyang maging adjacent. Depende sa reference angle na ginamit. So, below are the conditions in designating the side based on the reference angle. So, let's erase this. Okay. So, if the reference angle is angle A, so kung ang reference angle natin is etong angle, so this will be the theta. Then, A is the opposite side. So, etong A, opposite siya dito sa angle theta. So, A is the opposite side. While B is the adjacent side. So, kung A yung opposite sa theta or angle A, the adjacent is B. So, B is the adjacent. Okay? Pero, kapag naman ang reference angle mo is angle, if your reference angle is, but if your reference angle is angle B, so if this is your reference angle, angle B, this is your theta. So your opposite side from this theta is B. So siya na ang iyong magiging opposite side. The opposite side of angle B is B. While the adjacent side is A. So siya na yung magiging adjacent side. So the opposite side and the adjacent side really depends on the reference angle used. Okay, take note of that. Next. So to further understand the topic illustrating the 6 trigonometric ratios, let's consider the right triangle ABC. So this right triangle. So in this triangle, we let theta represents the reference angle, and that reference angle is angle B. So here is your theta. So this is your reference angle. So your reference angle is angle B. Then the leg denoted by A is the side adjacent to theta. So if this is your reference angle, the adjacent is A and the opposite is B. Okay? And then, from this figure, the 6 trigonometric ratios were illustrated below. So, ito yung table niya. By the way, we have 6 trigonometric ratios, but they are divided into 2. We have the basic trigonometric ratios and we have also the reciprocal trigonometric ratios. Once you familiarize or you memorize the basic trigonometric ratios, it can be easy for you to get the reciprocal of the trigonometric ratios. By the way, the basics are sine, cosine, and then tangent. And the reciprocal of sine is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So, how do we derive the ratios of this trigonometric function, sine, cosine, tangent, cosecant, secant, and then cotangent? We will base on this figure. Okay, we will base on this figure. Okay, so let's have first the sine of theta or sine theta. Okay, sine of theta or sine theta. So, sine of theta or sine theta is equal to opposite over hypotenuse. So, eto pala by the way is the acronym, yung SO. So, saan galing itong SO? S stands for sine, O stands for opposite, and then H stands for hypotenuse. So means sine theta is equal to opposite over hypotenuse. Yung ka naman, C stands for cosine, A stands for adjacent, and then H stands for hypotenuse. So, Ka means cosine theta is equal to adjacent over hypotenuse. And for the tangent, we have TOA. T stands for tangent, O stands for opposite, and then A stands for adjacent. So, once you memorize the basic trigonometric ratios, you will just get the reciprocal of these ratios. So as you can see here, the reciprocal of sine theta is the cosecant theta. So if in sine we have opposite over hypotenuse, in cosecant we have hypotenuse over opposite. So we just interchange the numerator and the denominator of the ratio. And if you will observe, cosine and secant are reciprocal. So in cosine, we have adjacent over hypotenuse. So pagdating dito sa secant, we will interchange the numerator and the denominator. So we have now hypotenuse over adjacent. So ganyan lang po. You will just get the reciprocal of the basic. And then tangent, opposite over adjacent. So for the cotangent, we have the reciprocal adjacent over hypotenuse. So we will just interchange this. Okay? So what does it mean by cho, sha, and cow? So C stands for cosecant, H stands for hypotenuse, O stands for opposite, S for secant, H for hypotenuse, and A for adjacent. And C for cotangent, A for adjacent, and O for opposite. So just remember SOHCAHTOA and then SOHCAHTOA because we will use that to illustrate the 6 trigonometric ratios. So let us now proceed to understand it better. So we have here practice exercises. We have A and B. So let's start first with the number 1 of A. So given the figure below, you have to illustrate the 6 trigonometric ratios. The first thing that you will do is write the 6 trigonometric ratios. So the 6 trigonometric ratios are sine theta, cosine theta, tangent theta, and the reciprocal of sine is what? Cosecant theta. The reciprocal of cosine is secant theta, and the reciprocal of tangent is cotangent theta. So to write the ratio of these 6 trigonometric ratios, remember of SOHCAHTOA for the basic trigonometric functions, and then SHO, SHA, COW. Okay, just remember these acronyms. So for SO, we have sine theta is equal, this is sine theta is equal to opposite over hypotenuse. For cosine, we have cosine is adjacent over hypotenuse. So this is adjacent over hypotenuse. And for tangent, we have opposite over adjacent. Okay. So for the reciprocal, if you get the ratio of the basic trigonometric ratio, you will just interchange the 2. Kapag hindi mo naalala yung SOHCAHTOA. So, i-interchange lang natin ito. So, we will write hypotenuse over opposite, and here we have hypotenuse over adjacent, and for cotangent, we have adjacent over opposite. Okay? So let's get now, or let's illustrate now the 6 trigonometric ratio. Wait, I will change the color. Okay, so the values or the lengths of the sides are 3, 5, and then 4. The first thing that you have to do is to identify the reference angle. So what is the reference angle? So you will see here the theta. So if the theta is here, therefore your reference angle is angle B. So we will base on this reference angle, angle B, to identify the opposite and the adjacent. So what is the side opposite to this reference angle? So the reference angle, the opposite side to this reference angle is, okay, so this is opposite. Ayusin ko lang. So this is opposite. And the adjacent to angle B is 4. And 5 is the hypotenuse. So to get the measure or to illustrate the 6 trigonometric ratios, so sine theta, what is the opposite? It is 3. So we will write here 3 over hypotenuse is 5. So we will write here 5. Therefore, your sine theta is equal to 3 over 5. How about the cosine theta? So your adjacent or the length of the adjacent side is, what is adjacent? Okay, 4. So you will write here 4. And then the hypotenuse again is 5. So the cosine theta is 4 over 5, or the ratio of your cosine theta is 4 over 5. How about the tangent? Opposite is 3, and then adjacent is 4. So your tangent theta is 3 over 4. So easy as that. So after you get all the ratios of the basic trigonometric ratios, again, you will just interchange the numerator and the denominator. So 3 will become the denominator and then 5 will become the numerator. So we have here 5 over 3. So your cosecant theta is 5 over 3. Your secant theta is 5 over 4. And your cotangent theta is 4 over 3. So easy as that. I hope you learned this. You learned this activity. So how will you illustrate the 6 trigonometric ratios of angle theta or the reference angle? Okay, let's go to letter B of this practice exercise. By the way, I know we still have number 2 of A. So again, to understand it more, let's answer this number 2. Okay, remember that the first thing that you have to do is find the reference angle. So your angle theta is the reference angle, and this is your theta. So angle A is the reference angle. So if angle A is the reference angle, opposite to angle A is side CB. So this is your opposite. And adjacent to angle A is side CA. So this is your adjacent. So this is your adjacent. And remember that the longest side is always your hypotenuse. Okay? So, the adjacent is 4, the opposite is 5, and the hypotenuse is 6. So, we are now ready to illustrate the 6 trigonometric ratios. Again, we will write here sine theta, cosine theta, and then tangent theta. So, remember again of so, ka, towa, and then shosha, cow. So means sine opposite hypotenuse. So your sine is sine is equal to opposite over hypotenuse. And cosine theta is equal to adjacent over hypotenuse. So adjacent over hypotenuse. And for tangent, we have tangent opposite over adjacent. So we have here opposite over adjacent. So after you get again the basic trigonometric ratios, you can now write the reciprocal. By the way, naubusan tayo ng space dahil sa aking panulat. So, isulat natin yung reciprocal. We have here the cosecant theta, secant theta, and then cotangent theta. So, we will just interchange the numerator and the denominator again. So, this will become the numerator and this will be the denominator. So, for cosecant theta, we have hypotenuse over opposite. For secant, we have hypotenuse over adjacent, and for cotangent, we have adjacent over opposite. Okay, so let us now illustrate the 6 trigonometric ratios based on this figure. Okay, so your opposite is 5. By the way, I will erase it muna. Okay, so your opposite is 5. So you will write here 5 over hypotenuse is 6. So 6. So your sine theta is 5 over 6. For your cosine theta, the adjacent is 4. So you will write here 4 and hypotenuse is again 6. So you will write here 6. But since 4 over 6 is still, or we can still simplify 4 over 6 by dividing both the denominator and the numerator by 2, 4 over 6 will become 2 over 3. So 2 over 3 is the simplified ratio of cosine theta. Okay? So if you can still simplify, better simplify the ratio. Next, for the tangent, opposite over adjacent. So opposite is 5 and then adjacent is 4. So tangent theta is 5 over 4. So wala na ako dito masyadong space sa aking reciprocal. So I will erase this. Okay, so by the way, again, to get the ratio of the reciprocal, you will just again interchange the numerator and the denominator. So cosecant theta will become 6 over 5. And then cosine theta, eto na yung, dito tayo magbe-base sa first ratio niya, hindi yung simplified ratio. Kasi secant, remember, secant is hypotenuse over adjacent. So your hypotenuse is 6. You will write here 6 over adjacent is 4. So if the result is still simplifiable, better simplify ulit by dividing both the numerator and the denominator by 2, so we have 3 over 2. So the final ratio of secant theta is 3 over 2. And for cotangent theta, we have 4 over 5. So, do you understand, class? If you have any question, you can write your question on in the comment section below, or you can just send me a direct PM or personal message. Okay, so letter B. Let's answer letter B. So in this activity, we use x and y instead of theta. Because remember that theta is the angle of a right triangle. And theta is the reference angle. And reference angle can be any of the two acute angles. So by looking at this illustration, okay, so x and then y, this is your y, sorry. X and y can be a reference angle because these are the acute angles. And z or angle z cannot be a reference angle because it is a right angle. Okay, so to get this ratios, or to get the ratios of this trigonometric function, sine x, sine y, cosine x, cosine y, and then so on, again, we will use the acronym SO, Ka, TOA, and then the Shoshakao. So, for sine x, this is equal to, again, sine is opposite hypotenuse. So, this is opposite hypotenuse. Again, sine ulit siya. So, this is again opposite hypotenuse. By the way, lagyan lang natin kasi later on may explain ako sa inyo. So, cosine adjacent over hypotenuse. Adjacent over, and then cosine again. So, this is adjacent over hypotenuse. So, cosecant. Ano ba yung cosecant? Ano yung reciprocal ni cosecant? It is sine. So, by the way, sulat ulit natin yung Shoshakao para hindi kayo malito. So, cosecant means hypotenuse over adjacent. So, hypotenuse over opposite, by the way. So, yung reciprocal ang cosecant ng sine. Kaya na-interchange siya. Second, the reciprocal of secant is cosine. So, this is secant hypotenuse adjacent. So, this is hypotenuse over adjacent siya. Hypotenuse over adjacent. Tangent is opposite over adjacent. TOA, tangent. Opposite over adjacent. And cotangent is the reciprocal of tangent, or yung cow. So, cotangent is adjacent over hypotenuse. So, this is adjacent over, adjacent over opposite. Okay, so yan na yung kanilang mga ratio. But we will find the value of the trigonometric ratio. Okay, so if yung angle dito is x, you will use this angle x as your reference angle. So, start muna nating sagutan yung may mga reference angle na x para hindi kayo malito. So, if this is your reference angle, x, etong angle x, your opposite is 5. So, this is your opposite. And then, the adjacent is 12. So, eto yung adjacent. And again, the hypotenuse is the longest side. So this is 13. Okay? So yung opposite dito kapag yung reference angle is x is eto, 5 over hypotenuse is 13. So the trigonometric ratio of sine x is 5 over 13. Okay, palampasan muna natin yung number 2. Dito tayo sa number 3. Adjacent is equal to, adjacent over hypotenuse. So what is your adjacent? Adjacent is 12. So lagay natin dito is 12. And hypotenuse is 13. So cosine x is 12 over 13. So let's go to number 5. Hypotenuse is 13. And then opposite is, eto again yung opposite, 5. So your answer here is 13 over 5. Secant x is hypotenuse over adjacent. Hypotenuse is 13 and adjacent is 12. So secant x is 13 over 12. So that is how you illustrate the ratio given a trigonometric function. Now, how will we answer this, or how will we illustrate the ratio given the trigonometric function with the reference angle of angle y? So next we will get we will illustrate the trigonometric ratio if the reference angle is y. So to do that, erase muna natin etong mga nilagay ko dito. Okay. So if your reference angle is y, so this is your reference angle. By the way, this is your y. If this is your reference angle or theta, what is opposite to your reference angle? Opposite is 12. So this is your opposite. And then adjacent is 5. So this is adjacent. And again, the hypotenuse is the longest side. So 13 is the hypotenuse. So we will now get or illustrate the trigonometric ratio if the reference is angle y. So opposite, what is the opposite? This is the opposite. Okay, 12. Over hypotenuse is 13. Therefore, sine y is equal to 12 over 13. How about cosine y? Adjacent is 5 and then hypotenuse is 13. So cosine y is equal to 5 over 13. And for tangent y, opposite is 12 and then adjacent is 5. So tangent y is equal to 12 over 5. And for cotangent y, adjacent is 5 and opposite is 12. So cotangent y is 5 over 12. So I hope you learned how to illustrate the ratio given a trigonometric functions with different reference angle. So if you want to go back to this, you can post this video and take a screenshot of it. And if you have any question, again, you can write your question or your comment in the comment section below. So for your evaluation, I will give you I will attach in the comment section the practice test. And by the way, thank you to the book of Bryant ML et al. 2017 and to these articles, BYJUS math articles. Okay, thank you so much guys, and I hope you learned from this topic. Bye!